In this illustration, we'll analyze a boat crossing a river. Here we are given that a man wants to row his boat along line AC to cross the river in which water flows at a speed u. We are required to find the minimum speed and direction of boat's velocity relative to water for this, and we are given to take the speed of river current as u. Now, in this solution here we can see if in this situation a man wants to cross the river along line AC, which is at an angle 45 degree with the direction of river current, and river is flowing at a speed u. Then we can see he has to row his boat in a direction at an angle say theta to the line AB over the speed v, such that when u is added to it, the resulting direction of boat velocity would be along line AC. So this is the resulting velocity. Now we are required to find the value of this angle theta at which this boat velocity is minimum and he'll be able to cross the river along line AC. And here we can see in this state the crossing velocity of boat, the speed with which the boat will cross this line AB is, say, if this y direction and this x direction, then here we can write velocity of boat in y direction will be v cos theta. And if we calculate the velocity of boat along a river flow, that is velocity of boat in x direction, then here it will be opposite to river flow, it is v sin theta, and along the river flow it is u. So we can write it u minus v sin theta. Now in this situation, as we are given that the resulting velocity is along line AC, that means in direction perpendicular to line AC, the direction, say if this is a line AD is drawn which is normal to line AC, then the two velocity vectors of boat, one is along x direction which is vx, another is along y direction which is vy, which is in this direction, this say vy. So the component of these vectors along line AD must be 0 so that the resulting velocity is along line AC. So in this situation here we can see for motion of boat along line AC, we can use in this situation, in this direction AD here we can see the component is Vx cos 45 degrees. So this will be V cos theta divided by root 2. This must be equals to the component of Vy along line dA, that is equals to u minus V sin theta divided by root 2. So root 2 gets cancelled out, and on solving this we are getting the value of V is equals to u divided by sin theta plus cos theta. Now we are required to find the value of V such that it is minimum and it is moving along the line AC. So here we can write V is minimum 1 dV over d theta is equals to 0, and here use a constant. If we differentiate it, this will give us cos theta minus sin theta is equals to 0, which will result tan theta 1 or theta is equals to 45 degree. This you could have directly evaluated by trigonometry, that the maximum value of sin theta plus cos theta will be when theta is equals to 45 degree. This implies here from the equation 1, we can write the value of V is equals to u divided by sin 45 plus cos 45, this is root 2, so this is equals to u by root 2 at theta is equals to 45 degrees. So this will be the result of this problem.